Hello and welcome to this section of integrating Knime and R together in this workflow tool. Uh, so you can write R scripts in Knime using this R no, this R node here, where there's some R snippets. Uh, the node repository there are like R source, R snippets, R view table where you can view the table and you want to convert into R, and then you can just there is also R learner and R predictor where you can write only the learner codes link means only that part which will do the learning process, and it will create a model object, and then it will and that one will work as a flow variable to the R predictor, and in the R predictor you can pass the test set, and then you can predict with that R model object. So in this tutorial now, I'll be showing you how to write R snippets, how to read files, and how to create some plots, and how to write R codes in it, and how to build these pipes together, and how you can do some clustering of some data. And I also create a QSR workflow here, how you can partition the data and pass it into the simple ordinary least squares model and predict the data, and can also some plots of regression plots using the XY plots. You will see later on in this video. So first, to read the file, just again you just see the configure, and you can read a CSV file, or you can read a tab delimited file, or you can there are various delimiters here: space, tab, semicolon. It's up to you what kind of data do you have, like a CSV or any other format, and it should be formatted in such a way so that this file reader can read it, and can separate into columns and so on. So then there's R snippet. So this while you once you read this, there's R snippet here. Let's see the configuration here. So the data which comes in from the file reader is called the Knime.in. So the Knime.in contains the data frame or what the file reader has read, and you can see here which has shown here the data frame type. That means that the variable where the data is stored is Knime.in. So to access the attributes, you need to write Knime.in $, in quotes, the name of the variable what you want to access. So suppose, for example, I want to know the correlation between sepal length and sepal width. So I can type into core.in, and so like that, and you can also see the stats here, and also the methods of different correlation like Spearman and Kendall. Or you can type, you can do something like this: data is then Knime dot in, and then what you can do is change, say for a1 equals uh, data. So, and you can remove this quotes here. And let's see whether this works. I think should work. Print a1, and you can evaluate the script here. So it doesn't work, so I think you need to give quotes. And evaluate the script. Yeah, it works. And see, you can see the correlation here. And so you can just pass the data frame into a new data, and then you can just then use that variable to compute other different types of data. So I'll remove it, and after you have done this computation, what you can do, you can create a new data frame. The variables what you have computed, you just do a column bind. Cbind is column bind, and pass into the Knime.out variable. So Knime.out, just is the final result which will pass into the next object for computation. So so what the thing is, after you compute, you can see the data output, which has this kind of table, and then A is this, B is this, and C is this. So, and then if you want to do some more analysis, you can pass this table into another node, and that will process that more data. So similarly for this one does some box plots. So you can see the image dot output can print the images like this of using the Knime data frame. What you need to do is uh, just call the box plot function, and then it pass the data frame inside, and it will automatically consider the variables and plot the data for you. And also there are histograms. You can print histograms also based on this petal length, or if you want to do petal width, you can print as much histograms here. Just as what the R function is, you can create par 2 by 2 and then create various histograms. And you can do the principal component analysis. You can do the two principal components, and for that you just do the configuration. Again, you just pass the Knime.in variable, and you detect and you then call the print_comp function and remove the species variable, and the remaining will be done on the numerical columns. And you want to scale the values, or if you want to center the values, you can use these two functions. And then want to print, so if you want to evaluate the scripts, it shows this. And then you can plot the iris.pca. It will color depends upon the type. Type is the last column, is the species class. So it will color the points based on this the class of, like, whether it is iris a class of species different. The next, if you want to split the data, you can also do it. So for example, you call the data frame, and just as you are doing in R, you can call those functions, or you can write your own. It will split the data for you, and then you can just pass the iris test set here, or if you want to pass the crane set, then you can do that. I will show you there are other techniques. This is not much as we expect, because we need to pass in a single node. We need to have two outputs. So for example, one for the train set, other for the test set. So what the partitioning node, it actually partitions the data into train and test randomly, and one node, the top node, passes the training set, and the below node passes the test set. So this one doesn't work. So you need to create another node and pass the train set, and which, like, just creating another node and make the workflow complicated. But anyhow, like, it still works fine with this. It's up to you what you want to do. uh, Also, there's another node here I created to do some normalization on the data. For example, if you just put in take the data frame, I am using the iris data set here. So the iris is very popular data set. It's like almost I think 300 values or so. So I normalize each column by the mean divided by the standard deviation, and pass the final data frame into Knime.out. So what does it happen is data output is this, something like this. So 1 2 3 4, it gets normalized. Uh, all the data get normalized and pass it into the final data frame for further computation. Okay, so this is how this is how you can create write functions using the R snippets. And there's some R. You can see here there are the various R resources, and also the names which is given. And you can also view the table, print box plots. So coming to this section of clustering the data, there are like various methods you want to do. So again, I just normalize the data, and I then run simple k-means on this first four columns of data, and then print it out. So it shows different types of clusters. The cluster, it depends upon you, like what you want. If you want to pass the clustering vector, you can pass the clustering vector, and then also you can just pass in something like this, just the data, and then uh, like this. So you want to C bind, say for example, Knime uh, C bind Knime.in, comma, uh, let's see what does this do. Okay, so this one prints the cluster. So what you will do is cbind Knime.in, comma, iriskm.cluster, and I will pass this to this variable. So what happens, the final output contains the full data frame, also the clusters on which they are assigned. So I'll just try to evaluate the script. It runs fine. Change this and just let me run it. So what you can see, the data output here, and it appends a column which contains the name of the cluster on which these classes are assigned to. But this is very simple. So just write. You need to know what you want as output, and that way you can write your code to to push the results to that node, to the next node, for further computation. And this is also the fuzzy C-means clustering. The fuzzy there. So if you want to load a new library, so you can call the library cluster here, and where you need to where the function which you are using, you need to load the library onto that. So you can call the library cluster, uh, and then you can run it. So before running the R nodes, you need to call the rserve. So you need to install the rserve in R, and after that you need to call the rserve using the library command. So for example, library rserve. So I actually installed the rserve because rserve is the R server, and Knime listens to the rserve which is running. So this the rserve is already running, and since it's already running, so that's why it's not showing anything. And after that you need to load all the libraries inside the rserve, or just if you don't have it, you can just call it using the install.packages command, and then you can just type the library command here, so that gets running. So before running the R codes and everything, need to run the R serve in the I'm running in R Studio. You can run it on R editor or in R Studio, it's up to you. So after similar to this, once you're done, so it will cluster it and it will produce. So if you want to evaluate the scripts, so again, so this prints the membership. So you can print the membership like this, $mem. If you want only the membership, okay, it's shows like. Okay, so again, if you want to do cbind Knime.in, then pass this to this variable and evaluate the script, apply, and at the end you can just see in which node is clustered. Yeah, so these are the different in groups where these nodes are getting clustered. So this is how you can write your own, R codes, and the final data frame you can pass it for further computation for the next node. There is also different way like Gaussian mixture decomposition. And there's also the DB scan I have done, and also the knife base if you want to apply knife base. So again, you just take the data frame and call this E1071 library, make a train sample of the first 150, and then just call this knife base function, and then just call this table predict function, and then just what happens you just need to see. So it gives you this nice table, and just if you want to pass it, then you need to write it, just this. So tab, say for example, and if you want to pass this one, so tab, and okay. So if you run it, so since I think it should be as dot. Since it's not a data frame, I think that's the reason it was showing error. Yes, data. Yeah. So it shows you this kind of relation is the required frequency of iris to iris set as 25 iris. This one to this is this, and like these are the false positives, and the remaining are classified correctly. And this is using support vector regression. So this is the same thing. So if you want to classify the thing and you want to print, so first you evaluate the scripts and see the petal width. If you want to predict a petal, I think they are predicting petal width based on the other variables, and then you just print the squared error here for every rows, and you get the output results. So this is how different types of algorithms work. And just remember, you need to use this Knime in, which is the find data frame inside the variable which the file reader has read, and you need to call this variable or change the name as like data equals Knime.in, and use that data variable as your computing data frame. Uh, so on this QSR workflow, I have installed some packages before performing this example. So it's the same workflow which is discussed in the QSR uh, um, video. So I use the QSR data package, and there's a data, the aquatic tox data. I actually call the QSR quick prop aquatic tox quick prop data, and then I bind this data with the activity outcome, and then change the name of the 51st column to activity and omit some data points which has NA values, and finally I put the Q data on the Knime out variable. So this very table shows this are the molecules, and these are the other properties, and the final activity column is this. Okay, so now coming to, we need to normalize and clean the data. For normalization, I am using the carrot package to pre-process the data here, because normalization will be method is based on the box-cox normalization. Uh, I convert the variable Knime.in in Q data, and then remove the NA variables, then remove the near constant columns, then also the R square, the correlation value, like give me variables which are like 0.29, like less or something like that, or you can just decrease it to like 0.2, 0.25 or something. Then after this, I pre-process D with the method boxcox, because the first variable is the name of the compounds and it's non-numeric, it's a string. So that method won't apply on that column. And then I just predict this, and then finally just you can see all the values. Since I did a head, all the values are kind of shown. This is a final variable which applying NA and removing constant columns, and also applying the correlation threshold. If you want, you can apply, otherwise you can keep as it is. And then it's up to you, just to show you that how do we apply this. And then we pass this final data to the Knime out, and we do the final computation. So here the partitioning node, which is available in Knime, not in R. This is a Knime node, but I draw randomly from from the data frame using some random seed, and this relative is like 75%, and the remaining test set will be 25. So at the top I pass the training set, which is 75% of the values, into the R learner. The remaining 25% comes into the predictor. Uh, the R learner script is like this. It's pretty simple, just an ordinary least squares model, and then you just pass this variable and the activity and the train data set here, and then it actually predicts the values. So it creates a model output here. You can see uh, the R predictor here. So it creates this model, the LM model. This is the variable, and you want to predict the Knime in. So once the model is created, now you want to predict the values of the old frame, and from that you compute those scores and try to correlate using R square whether these two values are kind of much similar or not, whether the model performed good or not. So, and then after that you just rename I just rename one column, so it creates a predicted Knime model. This kind of variable I change into predicted, and then I plot the figures here. If you want to evaluate the scripts, you can do it. So this is the adjusted residuals. This is the R square. It's 0.72, and this is the F statistic. So I just use this kind. This 5 lines of code here to compute all these values, and then just if you want to see the plot, it's just image.output, and this is the plot here, which shows the representation of the original activity and the predicted activity, and the regression line which has been fitted here. So this fitted is done based on the lattice package. I used a lattice package, and I called data.predicted, data.active, and these are the other variables. I called type R, which will plot the regression line, and the color of the line will be dark orange, or if you want to do it black, you can do it. And the line width will be 3. Similarly, so the remaining test set should be predicted based on this R learner model. So I pass this model here and test set here, and I view the results here, something like this, which is a very nice fit. And if you want to do some more, more just want to see the R square or everything, again what you want to do is just create that model, and then just compute the R square of the test set variables, like similar to this predicted set. How did I like this one? Knime predicted and active, and then you just pass this, and then after that you can compute the other scores here.